All right, so here's the experiment demonstration for conservation of energy, the bouncing ball. Now what we're going to do is we're going to collect data as this ball drops and bounces. So at its highest point, the gravitational potential energy is higher since it's based on height and its distance from the ground, which we can define the ground to be zero gravitational potential energy, since this type of function only matters if you're on the change in distance and not the actual distance from the center of the Earth and the center point of gravity. So, and at its lowest, as we will see, as its velocity increases, its velocity will be fastest just in that brief moment before it hits the ground, which, since kinetic energy has velocity squared in its equation, that means it'll have the highest kinetic energy as well. So let's go ahead and do this experiment and let's see what happens here. Alright, we got several bounces, and let's observe how many bounces we recorded on our data. We recorded 3.5 bounces, so we got 3 full bounces here, and this is our position function. So our position, when the position is at the highest, then since, as we just said, gravitational potential energy is dependent on position, then potential energy is at its highest as well. And it drops each time here. Now the whole goal of this experiment was to observe conservation of energy. Now what we observe on this second part of the graph, this black line is giving us our total energy. So energy is conserved within each bounce, but it does drop from one bounce to the next due to the loss of energy of the impact. But energy is conserved throughout the bounce, quite precisely actually, and that is why we use total mechanical energy to analyze certain situations. And again, this blue line is representing our kinetic energy, red line our potential energy, but the sum of the two is constant in each case separately. So that is a demonstration of conservation of mechanical energy due to a bouncing ball.